some equations of motion we have discussed here, some equations of motion. And before that, we have seen some what is this average speed, average velocities, and after that we have seen what is acceleration, what is speed, okay, what is velocity, and that all we have seen in the last class of last class. Okay, now we'll see some basic concepts of this physics which will be helpful for us in our further studies. Maybe after joining here the first PUC, it may be helpful for you. Just I'm trying to revise the basic things which we will get in your first PUC. Okay, in your first PUC. Let us try. Let us see some more. As we seen yesterday, what we have seen yesterday here, if you see the equations which you have seen is, one is V is equal to U plus AT. Okay, and the next one is, we are seeing this V square minus C square is equal to 2AS. And the next one we have seen this S is equal to UT plus of AT square. Okay, na? S is equal to UT plus of AT square. And the next one we have seen yesterday, that is a Sn pair. What is Sn? U plus A by 2 into 2n minus 1. So these are the four expressions which you have seen in the last class, right? Okay, na? Which will be much useful in our further classes here. Okay, na? The one expression is V is equal to U plus AT, V square minus is equal to 2AS, S is equal to AT plus of AT square, Sn is equal to U plus A by 2 into 2n minus 1. Got it here? So these are the expressions. Here we have to identify one point is when we have to use this expression and when we have to use this expression. This is to be used for the total distance traveled in n seconds, some time. And this is to be used in a particular second. Okay, distance traveled in 20 seconds. Distance traveled in 20 seconds. Distance traveled in 20 seconds means this one here. Distance traveled in 20th second means this one values. That's the main difference which we have to identify here. Okay, right now this expression when we have to use this for a whole time of journey. Distance traveled in whole time of journey. Whereas this one we have to use it in a few time of a particular time of in a particular second, in a particular minute we have to take it. Okay, na? Right. These are the things which you have seen yesterday. Okay. And before this we have seen one more. It is acceleration. What is acceleration? Means rate of change of velocity. Means V change in velocity. V2 minus V1 by T2 minus T1. T2 minus T1. Correct? V2 minus V1 by T2 minus T1 is the acceleration. Right now? So this is one which we have seen in the last classes, right? Right, I hope so. Now we'll see some more basic things here. Basic things in sense, I can simply say here the basic things here are what is uniform velocity? I'm going to see the uniform velocity. Uniform velocity. Uniform velocity. What's the uniform velocity? Uniform velocity in sense here, body is traveling with a constant velocity. Body is traveling with a constant velocity. When a body is traveling with a constant velocity, we'll get a that motion is called as uniform motion. What is it? Uniform motion. When a body is traveling with a constant velocity, we can say that the body is having the uniform motion. Body is having the uniform motion. Got it here? Okay, na? Fine. Means let's imagine you're going in a car, or you're going on a bike, you're going in a car. Let us consider. Okay, the driver is maintaining the speed of the car constantly. He was going at a speed of 50 kilometers per hour continuously. Got it here? Okay, na? So means that is either uniform motion. Uniform motion. Okay, non-uniform motion means quite opposite. We can understand then. What is non-uniform? Non-uniform motion. Non-uniform motion means here the body travels with a different velocities. Continuously its velocity changes. Okay. On the highways we can maintain the constant speed. Whereas in the villages, in small towns, we cannot maintain the constant speed here. Okay, that's what. Aeroplanes can maintain the constant speed, autopilot. Okay, I think nowadays in cars, cars of having the prices of around 15 lakhs or like this, we have a cruise control. What is that? Cruise control. Cruise control in sense here, if you set 60 kilometers per hour, it will go at 60 kilometers per hour. No need of keeping the foot on the accelerator. You can maintain constant speed like this. But be careful, okay? Cruise control, latest technology we have here in the recently coming cars, okay? Not 1 or 2 years back, from back 2 years we are getting that one. Means cruise control. Cruise control means the car will maintain. You have to set the car to go at that speed. Set it. It will maintain that speed here. Okay, we have to rotate the steering here. Here, a small advantage is no need of keeping the foot on the accelerator. It will go with the constant speed in this way. This is constant speed, uniform speed. These are some technologies which we are getting in our upgrading here, all the vehicles. Okay, fine. That is uniform and non-uniform. Non-uniform is it cannot maintain the constant velocity. Okay, na? It cannot maintain the constant velocity. Understood here? Fine. This is one which we'll have here. Okay. These are basic concepts or basic things. Or I can give one more definition here, that is instantaneous speed. What is it? Instantaneous speed. What is instantaneous speed? Instantaneous speed means that when a body is moving from here to here, let's consider different points. We're having A point, B and C and D, like this. Different points we are having here. Okay. In these different points, let's consider when the body is at here 20 kilometers per hour it is going. When a cycle, take it a bike, when it is here, it is at 50 kilometers per hour. Okay, it is going at 70 kilometers per hour. It is going at 40 kilometers per hour at the point D. At the point D, 40 kilometers per hour, let's consider. Okay, now when the body is going like this, its speed is not constant. It's a non-uniform motion. The body is in non-uniform motion. Got it? So here if you observe in this situation, what is the velocity at the point P? This is the velocity. This is instantaneous velocity. Means at that instant. What is that, Amma? At that a particular instant. At a instant we can say. At a particular time, velocity is called as instantaneous velocity. What's it? Instantaneous velocity. These are the basic definitions, which we will get in our further first PUC classes, sir. In first PUC classes, okay na? Okay na? Right, next. Now let us see some more examples here. Okay, some more examples we'll see here. What are these examples here? If you see here, let us see what we are discussing now. Velocity, okay, velocity, acceleration, uniform velocity, non-uniform velocity, and equations of motion we have seen in this topic, right? In motion is straight line. Now we will see some more basic concepts, some applications. What I mean here, let's consider a vehicle is going starting from rest. Starting from rest means u is equal to 0. What is it, Amma? Starting from rest means here u is equal to 0. Okay, starting from rest means u is equal to 0. Travels a distance of 5 meters. 5 meters in a time interval of 10 seconds. In a time interval of 10 seconds. Okay, the question here is, what is its final velocity and what is the acceleration? Simple questions here. Simple questions. What is the final velocity and what is the acceleration? What is the acceleration? How to calculate? Okay, na? So in this way we'll have some problems here. Try to way to understand the question and we have to simplify them. Okay, what we're having here is, if you see the question here, a body starts from rest. Starts from rest means u0. Having the displacement 5 meters in the time 10 seconds, what is the final velocity and acceleration? Simple question here. Very easiest question. Okay, means body is starting from rest. Means u is 0. U is 0. Okay, na? U is 0. And next, final velocity he want. and he want the acceleration also. And the distance traveled is 5 meters. And the time taken from here to here, the time taken is 10 seconds. That's what. Okay? Now how to get the answer for this? Nothing here. We know the equations of motion. What are the equations of motion here? Once write it. If it is required means you can write it. U plus AT. Okay? Next. S is equal to UT plus half AT square. V square minus U square is equal to 2AS. V square minus U square is equal to 2AS. Okay, na? Among these expressions, which one I have to use it? Check it. Check it. Among these expressions, which one we have to use? Once check it here. Okay, na? Now, if you observe in this situation, V we have to calculate here. Yes, U is 0, A we don't know, and T is also given here 10. Means in this expression, if I use this expression here, I don't know the V value, at the same time I don't know the A value, then no use of this one. Understood here? If I use this expression, as U is equal to 0, I will write it. T is equal to 10, I will write it. But what about V and A? Both I don't know here. Then no use of this expression. Next, go to the next expression. Is it possible to use this or not? Next, the expression which I am having, S is equal to UT plus R. Yes. Yes, sir. S is equal to 5 given here. U 0. Okay, U 0. And time, okay, T given 10. Of A, we don't know here. T 10. Yes, I can use this expression. If I use this expression, I will get an acceleration formula. I can get it right now. So what the expression I'm using here is, the expression which I'm using is S is equal to UT plus of AT square. Use this expression here. What is this? S is 5, U 0, okay, T, oh, T given na? And 10 into 0 into anything is 0 here, commonly, right? Plus of A, what is M? A we have to calculate, and 10 square. How much I'll get? Tell me from here. Just this is 0. Just simplify this one here. A by 2 into 10 square is 100. Okay, na? 10 square is 100, right? 10 square is 100. I can say here simply 10 square is 100. Got it, right now? Now if you observe in this situation, what I am getting here is 5 is equal to A into 50. This how many times? 50 times. 50. Okay, na? Therefore, A is equal to how much you are getting? I can write the A is equal to 5 by 50. How much I am getting? 1 by 10. Means how much? 0.1. So the acceleration of the body is 0.1 meter per second square. 0.1 meter per second square. Okay, na? In this way, that is simplified. See here, what we have to do is first try to understand what he has given. Okay, write the things. And among these expressions, which one have to use it? Check it. V is equal to U plus AT, S is equal to plus of V square and S square. Among these one, we have to check it. Substitute the values, we'll get answer. Now the next question is V, we have to calculate. It means now we want to find the V here. Okay, you can use this expression or this expression, anything now. Now we can use these two because I come to know the what is A value. A value is 0.1, right? A value is 0.1. Then I can come to know here what is A. Okay, fine. Now I'm going to use this expression. V is equal to U plus AT. Anything you can use it, no problem. V is equal to U 0. A is 0.1. Time, how much time you are given? 10 seconds, I think so. Yeah, 10 seconds. So substitute this, you will get the answer as 1. So the speed of the body after 10 seconds will be 1 meter per second. How much is the speed here? 1 meter per second. In this way. Okay, na? One more time I will try to recollect it. I will try to revise it once. See this, sir? What I am doing here is I am taking a body. Okay, a body is moving starting from rest. Starting from rest, right? Starting from rest. S is equal to, means the body is having a displacement of S. Time is 10 seconds. V is equal to G. V how much? A is equal to how much? That's what our task. Okay, for that. Once again write the equation here what he has given. Okay, U is equal to 0, A is equal to question mark, T is equal to 10, V is equal to 0. Among these three equations, one expression how to use it. Which one how to use it? Just check it. Just if you see here, if I want to use this one, I don't know the V value here, and I know the u value, a I don't know t. So it's not useful for us from the v is equal to u plus at, we cannot get the correct expression here. Now what we have to do, check at this, s is equal to ut plus half h square or a v square minus u square 2s, which one I have to use it? If you see s is equal to ut plus half h square, I can use, yeah, okay, right, fine, continue it. S is equal to ut plus half h square I can use, just substitute all the values here, you will get a value as a 0.1. Once if you know the a value here, okay, once if you know the a value come to know here, okay. Now I am going to use v is equal to u plus 8 expression here, v is equal to u plus 8, use this v is equal to u plus 8 expression here, u 0, a is 0.1, time is 10 seconds, so finally I got the v value as 1 meter per second square, okay na, 1 meter per second square. So this is the one speed I can get it after 10 seconds. This is the one problem which I am getting, okay, fine na? Right here. Now let us see one more if you want, we'll see one more example, basic number of examples we can, no problem, okay, I'll try it now, one more, okay, that is the easiest one which I'm seeing here, okay, let us see one more. Take it, a body is starting with a velocity of 10 meter per second. How much am I? 10 meter per second. A body starts from 10 meter per second. Okay, na? 10 meter per second. Now, some retarding force is acting. What is he was asking here? Some retarding force is acting. What is a retarding? Sorry, retarding force. I'll do one thing. Instead of taking this, I'll try to get one more small relation. The retarding force of, I can say here, the retarding force here acting is 10 Newton. How much is the retarding force here? 10 Newton retarding force is acting. Okay, na? 10 Newton retarding force is acting. On a body of mass also given here. Mass is 1 kg. What is the mass of the body now? 1 kg. Mass of the body 1 kg. Okay, na? Mass of the body, take it 50 kg. Anything, okay? Take it mass of the body as 50 kg. Take it mass of the body as 50 kg. 50 kg. 50 kg. Okay, na? 50 kg. 50 kg. Okay. Now my question here is, okay, after 10 seconds, what is its displacement? After 10 seconds, what is its displacement? What is its displacement after 10 seconds? Or 10, or take it only, you do one thing, take it only 3 seconds. What happened? After 3 seconds, what is this displacement? Okay, na? Means here the body is having initially some velocity, means body is moving here. Mass of the body is 50 kg. Let's consider a man, a boy, okay, 50 kg. Going at a speed of 10 meter per second in this direction. But some retarding force is acting. Retarding force means opposite direction. The force is acting in this direction. How much force acting here? 10. What's the meaning of this one here? Retarding force means now the speed of the body is going to be decreased slowly. Speed of the body is decreasing slowly. Understood here? Speed of the body is decreasing slowly. Okay, na? Right. Here my question is, after 3 seconds, what is the displacement of the body? Means starting from one point, means after 3 seconds, maybe here. Then he was asking, what is the displacement? You may get that, sir, force is acting in this direction. You are saying the displacement is like this. Try to understand the point here. Man is going in this direction, but some force is acting on him in this direction. Then what happens? Yes, the man's speed will be decreased, but the man is moving in the same direction. Man's speed is decreasing. What does the force do here? Speed of the person is decreasing. What is it here? Speed of the person is decreasing. Understood here? Speed of the person is decreasing, but man is moving in the same direction. Okay, na? Right. So here, which expression I'm going to use is S is equal to ut plus of a, okay na, t square. S is equal to ut plus of a t square. S is equal to ut plus of a t square. This one we have to calculate. U how much here? Initial velocity is 10. Okay. Time how much is given? 3. Right? Plus of A. What is A? A we don't know here. A is not given here. So what we have to do it, we have to take from here F is equal to MA. Correct? What is F? 10. Mass 50. What is A? A is equal to how much you are getting? Tell me now. 1 by 5 means 1 by 5 means how much? 0.2. 0.2. What is this force? This force is a retarding force. Retarding force means speed is decreasing. Okay, na? Right. Speed is decreasing. That's why I am taking the minus. Here why I am taking here as A is minus 0.2 because it's a retarding force. Speed is decreasing. Speed is decreasing. Here the speed is decreasing. Okay, na? It's a retarding force. Retarding force means decreasing speed force. By applying this force, the speed is decreasing. That's why I'm taking this one as a minus. Okay, into t square. T how much given here? I think so 3 seconds. 3 square. Just simplify this, we'll get the answer here. How much it is? Check it here. Okay, I'll write here. Okay, na? 3 into 10. 30. Okay, this minus I will write here. 0.2. 3 square is 9. So how much you get? 30 minus 0.2 cancels 0.1. So you will get this one as 0.9. So when you remove this, when you subtract this, how much you will get here? 29.1, I think so. Okay, the displacement of the person is 29.1 meter. How much he was traveling here? 29.1 meter. Okay, now one more time I'll try to I'll try to revise this once. See this one. Okay, got it? Fine. A man is maintaining a distance. See, a man is going at a speed of 10 meter per second. Okay, and on him some force is acting in this direction. Opposing force, retarding force, means this force decreases the speed of the man. 10. Okay, you after some time, after 3 seconds, what is this displacement of the man? What's the displacement of the man? Same, S is equal to ut plus of at square. Initial velocity is u10. Time is 3 seconds of A. What is A? From here I can get F is equal to ma. Okay, na? A is equal to, I'll get the expression as a 0.2. Okay, na? 0.2 I'll get here. So this is retarding I'm taking here. Why? Because I'm taking the retarding here. Acceleration means speed is decreasing. Speed is decreasing, and that's why I'm taking like this. 30 minus 0.9 gives you 29.1 meter. There is a small displacement which we'll have before after 10 seconds. In the same question, I can ask one more. After what time its velocity becomes 0? What's that here? After what time its velocity becomes 0? That's what we have to check it here. Okay, after what time its velocity becomes 0? What my question now it is? My question now it is, after how much time the body will become to same information here. I'm giving the same information, it's all same information here, nothing I'm changing here. Same information I'm taking here. Okay, same information here. Initial velocity how much? u10. Retarding force how much? 10 Newton. Mass of the body how much? 50. My question is, after how much time final velocity body come to rest? After how much time body come to rest? It's my question. After how much time the body comes to rest? Means final velocity 0. This is this. Which expression I can use here? V is equal to u plus at. See, there are many types of questions here. We'll use only these 3 or 4 expressions here. Remember that point, okay? Na? V how much here? 0. U how much is given here? 10. plus A how much we got previously, check it out, how much F is equal to MA, I remember this, MA, F how much, 10 given here, okay, M is 50, A how much, A is equal to how much we are getting, 0.2, okay, I'm taking this A as minus 0.2, why I'm taking this as a minus 0.2, why I'm taking, tell me, that's enough. Okay, now minus I'm taking here. Why I'm taking this one as a minus? Tell me here. Minus why I'm taking? Retarding force. Speed is decreasing. It is decreasing the speed. That's why. Okay, fine here. Now take it. T is equal to how much you'll get. Okay, bring this one. Left side 0.2 T is equal to 10. Correct, na? Minus 0.2 T comes left side here. Okay, na? Minus. Okay, na? Fine. Now if you take this T is equal to how much you get? 100 by 2 is equal to 50. Means it will take 50 seconds here. It will take 50 seconds here. What's it, ma? 50 seconds. It will take how much time, ma? T is equal to 50 seconds. Got it here? 50 seconds. Okay, na? Right here I got a message from someone. Class is not clear. Clear? Means some Wi-Fi is getting disconnected, some small gap we are getting here, no problem, continue it, okay, fine. So time after 50 seconds we will get this much here. Time is equal to 50 seconds, okay, na? Right, these are the problems here. Basing on this, if you find any other problem, try to do them here, okay, na? Try to do them here, okay, fine. These are the many examples we can discuss like this, we'll have many here, okay. So if you observe here now in this situation, now I'm going to see one more application here, one more example we'll see basing, please send offline video. Yes, offline video will be sent here, no problem. Okay, after completion of the I'm getting some messages, please send offline message, someone is sending, okay. Offline video will be automatically uploaded in YouTube here, you can click on the, after completion of the live class, you can, yeah, now okay, please send offline video, okay. Yeah, next time I will send it, okay. Nothing, offline video you can see which you are in group, you just click on the video, you can see in offline video also, no problem. Better, but try to follow online itself here. Why? Because offline means you will become a lazy fellows, right? Commonly, we'll see, like, tomorrow we'll see, evening 100% I will see, but follow the online. Online, why? Because I'll tell you the reason here. Online because we'll fix to a timing here. Yes, 12 o'clock physics will start, or 9 o'clock. Yes, 9 o'clock, what is this, we can say here, 9 o'clock chemistry starts, right? Or some 1 o'clock biology is going to start. So we'll fix to a timing here, okay? That's why best maximum follow online class only, okay? Na? Or offline means what we commonly feel, I'm telling here. Today 12 o'clock you may have any work, or you may be not feeling well, then you can use offline videos. Or else if you are very good, if your time is permits, go for online only. Understood? Okay, na? Right, try to learn the basic things here, we'll send it. Okay? No, someone is send the timetable, sir. And not a particular timetable we are having here. Okay? Not a particular timetable we are having here. Okay? Means morning 9 o'clock chemistry, afternoon 12 o'clock we'll start physics, and 1 o'clock I think so, around, yeah, 1 or 2 o'clock. Yeah, I think so, 1 o'clock only, 1 o'clock biology. Right? Maximum we'll follow this timing. Okay, na? Right, just for basing the basic things only here, okay, fine. Next, we'll discuss here, these are the basic things, sir. I'll tell you one more time, repeat it. The equations which we do, these are the major, very important here, u plus at, okay, v square minus u square is equal to 2as. S is equal to ut plus of at square. Okay, na? S is equal to ut plus of at square. And next, S nth is equal to u plus a by 2 into 2n minus 1. These are the expressions which we'll get here. Okay, basing on these expressions only, we'll have the maximum problems in motion a straight line or motion a plane, or these two chapters here. Starting is much important here, motion a straight line. Okay, na? These are the basic information about this mechanics starting here. Once mechanics started, we'll go further. Okay. basic formulas we can say, right? And tomorrow we'll see some other topic of basic concepts. In all topics I'll try to give some basic information only, okay na? Right? Why? Because it will be much helpful for you, right? Thank you for today, enough, okay na? Right, those who are not available in online here, okay, maximum try to present in online itself. If any by mistake, then take the offline videos. Offline link you can click on it, okay na? Okay, bye.